All right, everyone, welcome back. We were taking a look at density curves last time. Remember, we could have them being normal or not, but here was the example of a normal distribution. So this one was normal. Remember, because it was, it ended up being something that was symmetric. The mean, or mu, and the median are both in the same place. Balanced right there. The density curve always on the horizontal, and I should say on and above the horizontal axis. So really this is 0. You know, thinking about the height. And it should give you some indication, I suppose, about what this height might actually have to be, but it's not perfect. We say that the area under the curve is equal to 1. All right, so 100%. All right, we talked about it last week when we were looking at these normal distributions. We also talked about the standard deviations. Remember, here is mu in our normal distribution. A standard deviation, we looked at it, it ended up being the Greek letter sigma. I always thought it looked like an R. Ends up being the Greek letter sigma. And remember, when you have a set of data, you have one standard deviation, at least one value for the standard deviation. But we keep using that same value over and over again, you know, to get to the 3 points. You know, sometimes, and I believe, just kind of looking at the way that a lot of people would say this is, here is one standard deviation. Here is 2 standard deviations. Here is 3 standard deviations. And we would go same way going the other one, -1 standard deviations, -2 standard deviations, and -3 standard deviations. Now, again, remember when we're working with the standard deviation that we're really focused on this idea that if I have a set of data that has a mu, let's say mu ends up being 5, and it has a standard deviation of 2, remember that means I'm going to go standard deviation is 2, that's going to be 7, and then 9, and then 11, and going the other way, -3, -2, or excuse me, +3, +1 I can subtract, and then -1. So those are the numbers, -1, +1, +3, 5, 7, 9. So notice, and 11. So notice it's just adding and subtracting whatever that is, like -2 standard deviations is like saying 5 minus 2 times 2. Well, that's why it ends up being 1. All right, so that's the idea, that standard deviation, the width of all of these things, or at least the width, the value that we have here, they're all standardized, all right, away from the mean. All right, so the next thing we're going to take a look at in that standard deviation, again, this is a little bit of review from something we started to cover in Chapter 2 already, is that in this standard, or in this normal distribution, here, and let me pause this for a second. All right, there, that's a little bit better, better drawing than what I can do. Remember, in this normal distribution that we have, because the median's right in the middle, and these numbers, it's just showing you, you know, this again is how many standard deviations it is, you know, go in both directions. What this is saying is that, and the book kind of simplifies this a little bit, this is going to be the 68, 95, 99.7 kind of rule. 68% of the data is between the first standard deviations. All right, 95% of the data is between the second standard deviations, and you'll notice, and I think you'll get the idea, that down here 99.7% of the data between the third standard deviations. Now think about what that means. If I undo some of those ideas, if 68% of the data is between here, well, that leaves me with 100 minus 68%. That leaves me with 32% of the data on the outside. That leaves me with 32% over here and here combined, which tells me that these areas from the left edge of the graph all the way up to here is 16%. And from here all the way on is 16%. All right? So I guess the point is that if I were asking, what percent of the data is less than one standard deviation, whatever this number ends up being, I would know already it's 16%. So let's expand on that a little bit. If I have 95% of the data between these two numbers, and just for giggles and grins, let's say that this is actually, let's go with 50, 60, 68 inches. Remember, we're talking about heights before. Let's say that's 68 inches, and this is 70 inches and 72 inches, and 66, 64. So look, I have an average or a mu of 68 inches, and I have a standard deviation of 2 inches, and I've got them all marked out here. All right. This tells me if it fits this shape 95%, well, that leaves me with 5%. That means 2.5% of the individuals are going to be less than 64 inches. It also tells me that 2.5% of the people are going to be taller than 72 inches. All right, so that is kind of how we're using those numbers and being able to kind of divide this up into chunks. All right, so one of the things that might be helpful for you as you're working through this is to kind of put together this same graph, and let me jump over here and kind of show you how to start it. It's kind of put together the same graph, but if you can work backwards on this, like remember, this is 34% of the data because we said it's 68 in here, so this is a 34%. All right. Remember, this was 95% going on to here, which means 95 minus 68, I end up with that idea that we had before. So 20, oops. Oh, I'm done with the previous video, so yay. So 27%, well, remember that's for both of them. That tells me that right here I have actually 13.5%, and over here I have 13.5%. Notice when I add all of these together, I have my 95%. All right. So again, if this ends up being 99.7%, you'll notice I have 4.7, which ends up being 2.35% of the people, but I have that on both sides. All right, so I can kind of break up a graph like this. That leaves me, remember 99.7, that leaves me with 0.15. You can figure that one out, 0.15% on either side there. What that gives me is the ability to look really quickly and say, if I want to find, how many people are between -3 and -1, I can add these two together, 2.35 plus 13.5, and end up with 15.85%. If I want to find out the number of people that are between 0 and 2, I can do 34% plus 13.5% and say that this is 47 0.5%. That is how we are using this idea of a standard density curve and being able to break it up. Now, the last thing that we're going to do is figure out how do I apply something that's called a z-score that's going to help me figure out exactly where all the positions in between this kind of fall. So that's where we're at.